So far we have seen how to read the files into the data frame. Now let's take care of processing the data so that we can write to the target the way we want. We want to eventually partition the data by year, month and day of month. To actually take care of that, we have to add new columns. The columns can be year, month and day, or you can use whatever naming convention you want to use. I'll be using year, month and day. That being said, let's start with creating a program. The program name is nothing but process.py. Let me say process here. It will take care of creating the program using process.py as the name. Now I can actually define a function called as transform. It will take a data frame as input and it will return a data frame, but this data frame will have the additional columns. Now as part of this process, we will be applying functions called as year, month and day of month. There is a column called as created date as part of our JSON files. We'll be using that created date field and we'll be extracting year, month and day so that we can actually partition our data while writing into the target at a later point in time. Let's look at the data first and also explore the APIs so that we understand how we can actually transform the data. Once we explore, we will actually take care of implementing as part of our program. That being said, we have a subfolder called as data in our project directory. In this, we have this file. We'll be using this file to understand how the data look like and also how to use functions on top of the existing column to extract year, month and date. Now I can say PySpark. It will take care of launching PySpark CLI. Once it is launched, I can actually say df equal to spark.read.json, then paste this path. In this case, I am using relative path. That's why it is starting with data. As long as this path is correct from this location, it will work without any issues. If you find something like path not found or directory not found, you need to ensure that you pass either fully qualified path or correct relative path. Now I can hit enter. It will take care of creating the data frame. Once the data frame is created, we should be able to run this piece of code to print the schema. You can see that there is a field called as created yet at the beginning, which we can leverage to extract year, month and day so that we can partition the data eventually. You can see here. You can also validate by saying df.select created yet, then show. It will take care of printing the first 20 created yets. Now let us get into the details about how we can extract year, month and day of month from this created yet. For that, first we have to import appropriate functions. The functions are available under pyspark.sql.functions. You can say import year, month, day of month. Hit enter. You can actually say df.with column. We are adding new columns to the existing schema. To add new columns to the existing schema for a data frame, we can use this with column function. Then we can actually specify the column name. Then we can use the function. Then we can pass the column name as string like this. Now you can actually say show. It will take care of adding additional column. However, instead of printing everything, I just want to print created yet and year. For that, I'm saying select created yet, then year, then show. Otherwise, the schema is pretty big and you will be seeing a lot of information. It will be very tough for us to get consolidated created yet and year. For that reason, I'm using this approach. Now I can hit enter. You can see the date and the year part of the date. Like this, you should be able to add additional columns. Let me delete this and add additional columns. The additional columns are nothing but month. For this, we can use month function. We have already imported this, then pass created yet to it, and then day. For this, we can use day of month. This is also already imported. We can pass created yet to this as well. And then I can say select created yet, year, month, and day. It will take care of validation for us. Then we can say show on top of this and we should be able to see the date, year, month and day. This is how you can actually extract the information. As we got the required logic, we should be able to take care of implementing it here. However, we will not be only selecting created yet as part of this data frame. We will be directly using with column and we will be deriving year, month and day on top of existing data frame. For this, I just have to say from pyspark.sql.functions import year, then month, then day of month. Now I can actually scroll up, copy paste this entire stuff. Then I have to clean this up a little bit. This can be removed completely. Now we are returning the data frame with additional columns year, month and day. As we are done with the process logic, now we can go to app.py and invoke that here. I can say df underscore transformed equal to, first I have to import the function. The function is part of process. The function name is nothing but transform. I can say transform of df. Then I can actually print the schema for df underscore transformed, and also I should be able to select not only the repo.star but also additional fields such as created yet, year, and also month, then day. Now let me save this and let me run this. We have already defined all the required environment variables as part of the earlier topics, and hence we don't need to worry too much about changing anything as part of the configurations. Without changing anything, using the existing environment variables itself, we should be able to run this program after adding the transform logic. You can see the output here. On top of the repo related fields such as ID, name, and URL, we are also getting created yet, year, month, and day, because we have included those also as part of this select call. This is how you should be able to transform the data. Now we should be able to leverage year, month, and day to partition and write to the target. Let's get into the details about how to refactor the code to write to the target by partitioning the data by year, month, and day.